Alright, welcome back. We want to look at today. We want to look at how to account for shape variability. Maybe you just want to do that. I don't know. You may be interested in that because for individual disease, from the facial landmarks, you may want to know how does shape change. The shape changes in individual faces. Okay, the landmark shape variability. Want to know how things change, what causes changes in individual landmarks, which landmark points that account for the variability of the uh, of the shape. So we want to know this what will be done in MorphoJ. Okay, want to see the change how shape varies. Okay, or how the landmark varies in each individual disease in Fragile X and also in Williams urine. So you want to account for that or explain that, because if you say that there is a discriminant analysis, which means there is a distinction in the faces, which is shown by our test. ANOVA is also proved, which has been proven in our machine learning. Then you should be able to know that okay, something caused these changes. Since it is resulted from something, from the individual shape, this means their faces are not the same. That's what it means. They have different facial shape. So which landmarks that are causing this shape variation? So you want to know. So that will be done in MorphoJ. MorphoJ. So we are going to go to MorphoJ now. Let's open MorphoJ. All right. We are going to look at how shape variability MorphoJ. Okay. Now this is MorphoJ. This version 1.08.01. So you can download. It's free online. Okay. It's done in Java. So now just follow step by step how to do this. It's very easy. All right. But you need to understand. Now don't forget our file we had before. Our file. What's the name now? We have our file here. All right. This MorphoJ understand different kind of files. If you look at my importation here, if I open to MorphoJ, I'm trying to create new file here, new project here. See, you understand row columns. This row column is called CSV file. Okay, you can have a CSV file, right? You can have NTS file, you can have TPS file, or morphological file. So this one we already have this, but you might want to use this as well. This one is very common also in MorphoJ, all right? But we have this which can be read easily. But if you want to do this, because you may need this later, all right, for other things. So I will show you how to create that. So to create this one, go to past, minimize this first. Let's minimize it. Let's create another set of our file and keep it for further use. Go to past. Okay, open past here. This is my past. All right. So in past here, click on file, open. That's the same file. This is our file, our TPS file. You want to open it in past. All right. Pass your port to convert it. All right. Can you see it's open here? All right. So maximize. Now we have S1, Y1, S2, Y2. This is called it's actually CSV structure. All right, this is how CSV structure look like. Okay, for MorphoJ analysis. So you have this and you have this. All right, in CSV. So now what you do is that you have to copy everything here and to your Excel file in this format, in this structure. So what do you do now? You do like this. You select this. Okay, you select this. All right. This is why I'm doing that because why I'm doing that because I want to copy everything here, everything. Nothing is left. Everything. Okay. So that because if I select it, if I click here, you only copy the text for me. Only the text inside. The columns and the rows will not be copied. This particular heading and this particular subject observation will not be copied. Right. I want to copy everything that I will now filter out in Excel. So now I just click on select all. Say copy. Can you see that? So I go to Excel. Let me open my Excel. So this one will save you a lot of time. Okay, just try to save you so many times so that you not be just paste. Okay, can you see I've pasted. Now remove this line, delete this line, right? Then delete this line, delete this line. All right. You see now this one, name it ID. Okay, let's call it ID. That's all. We are done. We are done. This is how we do. So look at it. You see, this is our landmarks, official landmarks we have done. So this landmarks now is in CSV, but this CSV also is also called NTS. It's NTS format also, but the NTS format has some additional code on top of it. That's why those one has been removed. So we have it in CSV only. So this one can be saved. Okay, can you see no more? I think nothing more here. So can you see this 32 landmarks? Can you see 32 SY, 32 132, right? So you can see that this is how you do. So you now save as CSV file. Let's say save as, okay, save as our folder. Open here, say CSV, comma separated value. Call it combine. Let's say combine combine landmarks. Let's combine LM dot. You need to put dot. It says we just combine LM, okay, and save. Right? It's already in CSV format, so just save. So we are safe now. This is CSV file now. Now don't forget our naming convention that we use. Now this is very important for MorphoJ. This naming convention we have for fragile X. We started from F01, F02, F03, F04. This is very important because it must be consistent. Now we have total of 3 here. That 3 must be consistent throughout. Okay, 3 here. So you have to know how many observations do you have? I mean, how many subjects do you have? If you have up to 100 subjects, then that means you are going to have up to F001, F002, F003, F004, and so on. Then if you now have F100 and so on. So it will be consistent. So F indicates that it is a fragile X, and 001 means that it's a unique individual ID. You understand that now? Because that will be used to filter out 2 of them. In case you have 3 subjects, 3 groups rather, then you can do the same thing, okay, for each group, so that you can able to filter them out. So this naming convention is very important for MorphoJ, for you to be able to do a proper analysis in MorphoJ. You need to follow this naming convention. All right. So we are going to use this. So don't forget that F01. If you have up to 100, because I have less than 100, okay, that is why I'm using F01. If I have to 100 or above, I have to use F001, F002, F003 to F100, all right, or 200 or 300. If I have 1000, I mean F0001, F0002, F0023. You understand that now? Okay, let's move on. Now, this is our landmarks proposition. Okay, S1, Y1 for the first landmark, S2, Y2 for the second, S3, Y3 for the third, S3, Y4 for the third. So don't forget what I showed you in the slide, the phase points where they are located, S1, Y1 for S2, Y2. Don't forget point 1, point 2, point 3, point 4, point 5. That's what it means. Okay, so you will see that further in MorphoJ how we got that. So we're going to first use a TPS first, and we also use this so that you can know that you can read both of them. So let me quickly upload. Now this one we are done here for now. All right. So let's go to MorphoJ now. Click on File, create a new project. So let's call our project. No, I don't want to call the project now. So let me just no name for now. All right. It's 2-dimensional. Okay. Leave the setting like this. Now we go to row columns. This one. So let this now. Browse here let's browse our document here. Let's look at the file. Okay. We have what's the name now? Combine LM. Okay, combine LM.csv. What is it? So we open this first. Okay, let's say we create dataset. All right. Our dataset name is new dataset. Our project name is new project. Okay. For now, just to see it reads without error, no error. Without error, it will show you here that you should finish reading file. That means the file has been read. So you can see the file here, okay, in your tree. You can see this new project dataset that's come. So which means it read this. Okay. Now let me see, let me confirm by creating new Procrustes fit here. Just go to preliminaries, select Procrustes fit and click on perform here. Don't change anything, just click on perform, just perform. Can you see here? So now let's go back again and do again now. We are going to close the other, or to cancel this. Okay, new project. We don't want, okay, want to create another afresh. That's what it means. So this one already been here. Let me just close. So open it afresh. Let's MorphoJ now. So I just want to show you the two, how you can bring the two in. All right. So let's now use the second one now. The TPS file. All right. TPS file. Our TPS file will be from the same place. All right. TPS file. Look at it here. All right. Let's create now. Bring that one in. Can you see it? Finish reading. Look at it here. So two of them can be used. I just want to show you that this is how to make your life easier. All right. That thing that's a CSV file. CSV file I just created now. It takes a lot of time to do it for many programs, but I just show you a very fast, easy method to do it. All right, without any stress. So now you can now go further now and do your Procrustes fit. Any one of them can be used. Okay, do the same thing I did before. So same thing. All right. Okay. Now that we have this, what you need to do is that we want to split our okay, you can just rotate, okay, rotate twice, clockwise, again, rotate clockwise again, so that you can see so this is how it look like. So you want to look at numbers here, numbers here. So maximize. But now before that, let's I want to quickly extract. Okay, let's extract before we go further. Since we have before we do our covariant matrices, we want to extract. Let's extract before we split. Extract new string from the identifier. So you say extract new and classifier from ID string. So come here. Want to split it, want to extract it. Okay, to create a different set for each of them for each disease. Okay, so we want to say, let's say we have a ID. Our ID is just 1 to 1 2 3 1 to 3 1 2 3, right? That's our ID. It's unique for each of them. You can execute, right? Execute. Go back again. The preliminary, say extract. This ID is already done. Then we want to have a disease. Can we call it disease? Let's call it disease. Disease. Now, this is what you mean. This is F. Don't forget F. This one W. F for fragile. So just say 1 1 1. You understand that? So it means the first one. Okay, the first one, that's what it means. 1 1. So last character 1, first character 1. So we are not going before 1. So the one, just one throughout. Okay. If you have fx, maybe I have fxs now. wbs to be 1 to 3, 1 to 3. Right. So this 1 1 now. So just execute now. Right. So now when you do that, you now come here, go to edit classifier here. Click on edit classifier after you have done that. Can you see? You have ID, unique ID for each of them. You have disease here. All right. Can you see disease? So you see, that's separated the disease. So here, you can just say, click on here, right? Disease. Click on replace values, right here. Replace values. Open it. For F, change this one to fragile. X. Click on replace all. Replace all. Done. Then open here. For W, replace this one with Williams. Okay. That's a Williams B. All right. Then replace all. Done. That's all. So you have fragile S and Willis B here. Okay, so to differentiate our two. So we have done that. Then we can now accept. Maybe I don't accept. That's all. So now we have differentiated. You can now come here and you can now create what they call. You can split two of them. Okay, I may split it if I want. If I don't want, I may leave like this. All right. Okay, so because I already have the affiliation, so I can go to I'm going to generate my what they call it now, covariant matrix first here. That's the next step. So after don't worry, this one is selected first. Then click on execute. Okay, go to relation principal components. And you can rotate, flip, rotate. So you can see this is what we have in our shape. If you remember in my slide, this is what we have there. This as region 1 to 2, 3 to 4, okay, 5, 6, 7, 8, 9, 10, 11. This is what we have. Don't forget. Okay, you can see how shape changes here. This is your PC score. All right, this is a eigenvalue. All right, for general one, this is for general one now. We have not split it yet. All right, for general one, for everything, for both. But we are not looking at this. We don't need this actually. We don't need this. We need for each of individual disease. That's what we need. So what do? Okay, we come here. We want to split. All right. We say here we want to create here. Where's splitting here? Okay, so divide. Here on divide here, okay. So select disease, all right. You can see the two of them here that we just created now. So you now click on execute, right? Execute here. So when you come to your tree, under tree here, you see two of them here, one here. This is one data set here, another data set here. Under this general data set. So you want to select this one, okay. You now click on preliminary, generate covariant matrix. Click on execute. Click on this also. Generate covariant matrix. Execute. All right. So select this as well. Select each of the covariant matrix now and click on the principal component. All right. Go back again. Yeah, I've done for this one now. I've done for this. This one is fragile X now. You can see fragile X. You can rearrange. Just rotate clockwise. Rotate clockwise. So for fragile X shape. This is how it shape. How it look like. Okay. This is how it look like. You see that? This is how it look like. So fragile S shape. Now you need this particular shape now. Okay. You can right click on it and save. Right. Export file. Right. So you can save. Let me just save in our same folder. Create a folder called Morpho. Let's call it Morpho. Right. So let's save inside here. So we're going to save it as a let's save it as BMP file first. Right. We're going to crop out some things okay later so that it can be heavier to do. So just save you can say MPG or whatever. So but let's save as a PNG first. Ready first. Before that, let's make it let's see if we can increase the size of the point. Let's make it 11. A bit more bigger. Okay. So you can save now. Use 11 point. Don't forget for the first one. Save now. BNP. This is PC1 dash fragile S. Okay, that's a fragile S. Export to our folder. Move files. Okay, export. Right, so that one is done. This we need this PC1. We need only this. Then for the second one, which is this one. Okay, let's create a Procrustes analysis for that also. I want to see how shape changes. Okay, now you can clockwise, so you can see here how shape changes. We need to analyze this later and describe it, right? So you can make it a size 11 points. Okay, so that's okay, 11 points. So you can save this one now also. Export to the same place. Okay, PMP. The PMP is big. That's why I'm using PMP. Okay, this Williams. Okay, let's call it Will. Export. So we have both each of the shape for each one now for both fragile S and Williams. Okay, you can see Williams here. So we have the shape of them. So we see how the shape changes. Can you see? Look at the direction of the landmark here. That is direction. So we need this to analyze our shape changes. Okay, look at it for this one. As it's different. See how it is different. Look at the direction of the landmarks is different here and here. They're not the same. So you need to analyze it to explain this. Alright, this is called lollipop graph. This is called lollipop graph. Okay. Then we also need something to before we go. We need to for the general one that we did before, which is this one, the general data set. We don't need this, but we need the PC score for that. Okay, the PC score. We can make it bigger. Decide the point. Let's make it the point 8. Make it bigger. Okay. Now in this point, you are going to color it. All right. The PC1, PC2 to color it. Let's color data points by click here and open here. It's by disease. So change this color. I don't like this color. Change it to maybe to blue. Fragile S is okay for red. Change it to blue. Right. Click on use this color for this. Okay. So we have red and blue for this. Okay. So you click on OK. All right. You can see now this is your. You can see this fragile S. This Williams B. So this is our principal component analysis. Okay. For each of them. So you can save this as well. Right click. Export. So PC1 versus PC2. Okay, open here as BMP, right? Save. Okay, this is a PC1. This PC1 versus PC2. Okay, PC1 versus PC2. Just export here. Now we have what we needed. That's all. We don't need this. Okay, we don't need this for here. This one general one. Okay, we don't need that. Okay, we don't need this as well. If you like, if you want to look at variance, you don't, no problem. But I don't need it. Okay, it's not necessary. Right. So this is what we need. General one for PC score, right? Which you have seen here, right? Then we need individual what they call it, individual fish. Each disease's mean shape. Okay, this is called mean configuration shape now, right? So that is what we need for now. So I'm going to stop this here so that you can. I will not use too much time. Okay, so that the next class will now continue from there. Thank you. See you later.